Jai Hind everyone, myself Puneet Saini, Assistant Professor Mechanical Engineering Department, Ajay Kumar Garg Engineering College. Today I will be talking about subject Mechatronics. It is taught in BTech 5th semester for Mechanical Engineering students. It is a departmental elective subject. Today is our 4th lecture of complex lecture series in which we are doing a complex topic from each of the 5 units that is in our syllabus. So till now we have completed 3 complex topics from each of the first 3 units, and today we will be talking about unit 4 and we will be discussing about PLCs, its application and its types. So let me first give you a brief recap of what we have studied till now. So it is an 100 marks paper, and in unit 1 we discusses about the mechatronics introduction, in which we have discussed about what is the definition of mechatronics, its scope, its evolution, its applications in the areas of autotronics, bionics and avionics, and we briefly discussed about the control system concepts. Control system meaning the brain of any electromechanical system. In second unit, we discussed about the input devices, which are sensors and transducers. So essentially, an system consists of a controller, which is nothing but a brain, which decides whether a specific task has to be completed or not. And how it decides that? It decides by gathering information given to it by the help of input devices, which are nothing but sensors and transducers. So sensors and transducers are input devices, which fed information to the controller. So second unit deals about the sensors and transducers. In third unit, we discussed about the actuation system. Actuation system means output devices. Output devices which gives us some kind of output. So in output devices are further divided into 3 types according to our syllabus, in which we discuss about the fluid based actuation and electrical based actuation. Fluid based actuation deals with hydraulic actuation and pneumatic actuation. Pneumatic means when you are doing some kind of work with the help of an air pressure. And electric actuators examples are motors, servo motors, types of motors. So this is what we have discussed in unit number 3, actuation system, which is output devices. And unit 4, which we will be covering today, deals about the industrial controller. Now PLC is a type of industrial controller. Its full form is programmable logical controller. Controller, as I just discussed now, is nothing but the brain, which decides whether a specific task is to be completed or not. So today we will be discussing about unit 4. In unit 5, which we will discuss in our next lecture, deals with the mechatronics applications, in which we will be covering about specific case study of mechatronics, like how an pick and place robot works, or how an engine management system or automatic car system works. So let us now start our unit number 4, which is nothing but PLCs. So before diving into the PLCs, let us first discuss briefly about what do we understand by a controller. Controller, as the name represents, it controls something. So a person or thing that directs or regularizes something is known as a controller. Now controller in a computing context, if I talk about a computing context, is a hardware device or a software program that manages or directs the flow of data between 2 entities. So an example is given as a PCI Ethernet controller and a PlayStation controller. I think we all are familiar with this. So it is a joystick. When we play it on a PlayStation, it is used to control the character which is there in the game. Similarly, this is an example of in a computing context. With the help of this controller, you can control the aspect of the player. If you are in an open source game, you can control where that player will go or what a specific mission that player will do. Now, if I take more of an open end example, if I take an example of a classroom. So in a classroom, there is a professor which teaches some topic to students, and there are students which are sit which are there in the class to gather some information, to gain some knowledge. So a professor is a person who dictates the class, who provides the knowledge, and he controls the class. If some student is creating a nuisance, or he is or she is not paying attention, then professor has the authority to take action against that student. So at that moment in a classroom, we can say professor is a controller, which is controlling the classroom. So same here, if I talk in a computing term, this PlayStation or this controller, both are used to control specific tasks in case of a computer hardware. Now, a controller is nothing, as I have told earlier, controller is nothing but a human brain. Now, our body responds to complex command and impulses to get these tasks done. For example, if I say that in front of me there is a table, and on that table there is a pen. So I just have to thought about it, that I have to take this pen in my hand. So just there is a really good coordination between my head and my hand. So my head is giving command to my hand that I have to take my hand towards that position, and I have to grab this pen. Sorry, and I have to grab this pen. So this command is given to us, to our hand, by our brain, and this is how a brain controls our whole body parts. So our body responds to complex commands and impulses to get the task done. I think it is right. So we don't think about what it overtly, but the truth is our brain performs complex biochemical and behavioral procedures very easily. It is very easily, and it is quite difficult to teach those tasks to a computer. So our brain is an extraordinary controller. So what we try to do is we try to make machine in such a way that it is as near as intelligent as our brain. So what are the 3 steps involved for our brain to do that? It is involving learning, information processing, memory to accomplish even the most seemingly mundane or difficult or boring task. So this is how our brain perform all these kinds of operations. Now, to understand the analogy between controller, a controller can be thought of as a human brain. Now in controller, what is if you see this task that a controller do and you correlate it with the brain, you will see that our brain perform exactly same functions. Like, this is what a controller actually looks like. It can be an industrial controller. Now what it does is, it is an intelligent system, meaning it will be able to do decision or take decisions once we teach it how to do it. There is a complex processing unit in it, central processing unit in it. There will be a memory to store all these programs, and there will be a processing power to conduct all these programs, and there is a power requirement to it. Now if you compare it with our brain, essentially our brain has all of these kinds of function. It is intelligent. Our brain can be set to comparison with a CPU. It has memory, in which we store some events. It processes things, and it requires powers. As we eat different food, it gives us power, and it gives our brain power. Now, if I talk about controllers, it is essentially consists of embedded controller and an industrial controller. Now, industrial controller is further divided into 2 types of controllers. First is single loop controller, another one is multi-loop controller. A single loop controller is discrete on and off controller. Very simple. It can be set as a switch in our household to switch on a light or switch off a light. It can be a PID controller. And multi-loop controllers are examples are PLCs and DCS. So let us study these one by one quickly. So what are embedded controller? Embedded controller is a microcontroller chip. It's a very small in size. That's why it is known as microcontroller, and it is put in computers that handles various system tasks that the operating system does not handle. So OS is not handling that task. That task is handled by the microcontroller. For example, device used in our daily life, consumer electronics requirement, for example, mobile phone or remote, or and it requires more functionality, maximum efficiency, flexibility, and features. So these are all the features of embedded controllers. Some of the examples it are like camera, PlayStation, washing machine. These are some of the examples of mobile phone embedded controllers. And industrial controllers are single loop and multi-loop controller. So let us study about single loop controller. If a system requires a single control loop or a discrete device, then the single loop controller can be used to control a thermal or process machine. Now here we are taking example of a thermal machine. If it requires only a single loop of controlling efforts. Now single loop means you use one feedback signal which is directly influenced by the controlling medium. Now feedback signal is is something, for example, there is a room air conditioner and you have set the temperature as 25 degrees Celsius. Now the outside temperature is 25 degrees Celsius. As you have switched on the AC, earlier the temperature was 28. Now the air conditioner have to work in such a way that it reaches the 25 degrees Celsius temperature. As soon as it reaches the 25 degrees Celsius temperature, it will turn off. So this signal, so how the controller will be able to know whether the 25 degrees Celsius temperature has been reached or not? It is by the feedback mechanism. There is a temperature sensor there which automatically sends the temperature whether it is have met the requirement of the set requirement of the 25 degrees Celsius. Then if it is reached, then the loop is completed and we can say that our task is done. So if there is only one feedback loop applied, then we can say that it is a single loop controller. Now, if you are controlling a valve which adds hot water to cold water to control the outlet temperature. So if there is a valve in which you are adding hot water to cold water, then it is known as single loop controller. Example is this: you vary the valve to directly control the outlet temperature. The control loop only uses temperature as a control factor. So there is only one control factor which is temperature. So this is an example of single loop controller. Next we will study about multi-loop controllers. So if you have more than one control loop within a single system, then the multi-loop controller can be used. More control loop means more feedback signal is consistently sent to the controller. In simplified term, a multi-loop controller can be thought of as a multiple temperature controller within a single instrument. The controllers are typically programmed using a proprietary software program on a PC which downloads settings to the multi-loop temperature controller using communication. So there is a proprietary software which is fed to the PC to download different multi-loop programs. So this is what multi-loop controller is all about, and its diagram is seen here. So multi-loop controller essentially look like this. You may vary the value to control the hot water flow. So how much temperature is needed for hot water? Suppose 18 degree, suppose 40 degree, 45 degree. So how much hotness is required? It is decided by the multi-loop controller. However, the flow set point is controlled by a loop which uses the outlet temperature to determine the appropriate hot water. So this is what multi-loop controller is all about. Now here comes what was the essentially need of PLC. So the controller is designed in modular form so that sub-assemblies could be removed easily for replacement or repair. So we need to repair control system, and this was the requirement which was felt. So the control system needs capability to pass data collection to a central system. So this requirement was also felt. Reusability was felt. The method used to program the controller is simple so that it can be easily understood by the plant personnel. So it should not be called complicated, right? So this is what was the need of PLC, and this is how PLC was came into origin. So what a PLC is: a PLC monitor input makes decision based on the program and controls output to automate a process or machine. They are used in commercial industrial applications, and they can also be connected to the outside world. Let me give you a quick example of the applications of PLC. Now PLC can be used in we can say good example is whenever you go to airport and you check in your baggage, simply in the airline counter, the package goes through the conveyor belt. Now suppose if you are going from New Delhi to Chennai, now how the airline decides that that your package will go to the exact same flight which you are boarding, because in airport there are multiple of flights which are boarding after a few minutes. So it depends, that is checked by the controller. As the conveyor belt progresses, there is a sensor or a scanner put on that, and the controller and scanner decides whether this has to be boarded to the said flight, and it diverts the conveyor belt in such a way that it reaches to the correct destination. So the scanner scans the baggage slip which is put on by the aircraft company, and it tells which place that baggage has to go to the aircraft. So this is where the application of PLC lies, one of the application of PLCs. So what PLC do is, PLCs, it sees the input data, process it, and then outputs the results. The process is performed in 3 stages. So PLCs, its output, it can be used to for switching on the lights, for driving the motors, pumps, push button switches, and it gathers information from sensors. Benefits of PLCs are logic control, arithmetic functions, timers, counters, analog signal, PID control, real-time function, HMI operation, communication abilities. So these are some of the complex functions like arithmetic and logic control, which can be performed with the help of a PLC. And advantages are, it's very compact. It can be as small as this, and it can be big also, depending upon the application. So it reduces space, it's energy saving, it's very rugged. So the chances of damaging of PLC is very, very less. Its maintenance is easy, it's economical, it has greater life, flexibility, shorter project time, and documentation is easy, and communication abilities are very high. So these are some of the advantages of PLCs. And areas in which it is used is manufacturing, food and beverage, metals, powers, mining, petrochemical, textile, automotive, packaging. So there is not any field in which PLC is not used till now. So some of the leading PLCs in market manufactured by different companies are, American is Allen Bradley, is a manufacturer of this PLC, and as you can see, Allen Bradley PLC looks like this. Modicon, one of the manufacturing company, an American company, Texas Electric, Westinghouse, Square D, and European is Siemens, Festo, some of this Klockner and Moller, Telemechanic, one of the companies which are manufacturing the PLCs. Japanese is Toshiba, Omron, Fanuc, Mitsubishi. Now let us see what are the types of PLCs. So types of PLCs are fixed, which is fixed at one place, and modular. You can disassemble it and you can take it to some place else. So it looks like this. Now PLCs are identified, classified, and procured according to its range. So it is divided into 4 types. First is micro, which is nothing but small PLCs, mid-range PLCs, large PLCs, and soft PLCs. So micro PLCs, it's like, it depends on the size, how many input or output devices can be attached to the PLC. So in micro PLC, it covers up to 128 input output devices. In small PLC, they are capable of providing sample. Mid-range PLCs have, again, as you can see, it has 2048 input output devices, substantial increase. Large PLCs are very large, and their memories is also increased up to 750 kilobyte. So memory is the space where programs which you are feeding, programs which are you are setting as an instruction, which will the PLC will do, is it set here. And soft PLCs are PEC based automation, and PLC and HMI is integrated, means there is a screen there and there is integration in the same place. So these are the range of PLCs upon the memories and input output devices. Now how do you select in PLC? Is that which task is required by you, application requirement, what is the input output capacity is required, type of input output is required, what is the size of memory required used to store the program, speed is required for the CPUs, electrical requirement, speed of operation, communication, software, operator interface, physical environments. So these are some of the selection criteria of PLC, and it depends entirely on the user. What kind of applications is their requirement? Do they want a small one, or do they want a larger processing capabilities? So that is how you decide which PLCs you want to procure, and from the different companies which are present in the market. So the system requirements for selection criteria of PLC, the starting point in determining any solution must be understand what is to be achieved, like how many input output devices is required, how many memory space do you require to install in a PLC. So the program design starts with breaking down the task into number of simple understandable elements, each of which can be easily described. So this is how you decide what kind of PLC do you require. Application requirement, if I say, it depends upon what kind of applications you are using. You list the function required, then you need to special operation which is required on and off, and list the advanced functions required besides simple discrete logic. what kind of advanced function do you require, and it depends on the applications. Next come the electrical requirement, like how much power do you have, input device voltage do you have, and output voltage current do you have. One of the selection criteria is speed of operation. How fast do you want those speed to be, how fast do you want the speed of it, and our time is a critical function for you, and what time frame must the fastest action occur. So this is what speed of operation is all about. Another criteria is also communication. If the application requires sharing data outside the process, that is communication. So communication involves sharing application. For example, you are sitting in some different place and you want to see and you want to control what kind of operation is happening in your industry. So you can control it with the help of this. So communication is very important. Whether it is an IoT enabled device, you can control it remotely. So it depends on the requirement also. Communication can take place locally through a twisted pair wire or remotely via telephone or radio medium. Operator interface is also important. If PLC is easy to operate, then it is very easily understandable by the people, and more they will be able to use it quickly. Training time required for the people to learn that PLC is also less. So if a system needs operator control or interaction in order to convey information about machine or process status, or to allow operator to input data, as I have said. So traditional operator interfaces include push down buttons, pilot lights, LED numerical display. So these are some of the important operator interface which is there put on the PLC for operator to understand very easily. Physical environment, where the PLC is being put, or which control system where it will be located, environment in which it will be put up, like in a harsh environment, house control system, IP rated if there is so much, if there is amount of moisture is there, and if it is more prone to water, then IP rating is important. Maintenance, troubleshooting, reprogramming, all of these depends on the physical environment. So the topic which we are seeing till now, it is the selection criteria of the PLC. Like how do you decide which PLC you want to procure? So these are the selection criteria. Now PLC's architecture. So PLC architecture is like this. There is an input device. Input can be form of a sensor. There is a CPU and there is an output device. PC for programming, and there is a requirement of PC, so you can program the logic into the PLC. And this is what an internal PLC looks like. There is an input processing unit, there is a CPU, there is a memory which stores the program, there is a power supply, there is a communication, and there is an output which you want to control for output lines. Elements of PLCs is a CPU which performs all the operation. There is a power supply unit which supply power to the PLC. For example, in our diagram it is shown as 24 volt DC power supply. Next is input output sections. So this is what PLC looks like. There is a push down button and there is a switch also in which you control the input output operations. There is an expansion modules. Here the two PLCs can be integrated to use as one. There is a memory unit where you store the programs and control actions, and there is a programming device also. It is used to enter the required program to the memory of the processes. Now let us study about the memory. PC contains RAM and ROM both. There is an executive memory. I won't be going into the depth of that. You will be able to understand it very easily. There is an executive memory which is also known as ROM. There is a system memory. There is an input output status memory which is RAM memory, data memory, and user memory, RAM, EEPROM and EEPROM. So these are some of the memories which are included in the PLC, in which you are able to store your programs or logics function which you want to do regarding a PLC. So important term in PLC is a scan cycle. Scan cycle is nothing but it determines from the starting of the program to the conclusion of the program how much input output processes or time it has consumed. It contains of reading input and updating input image table, processing as per logic, and updating output table image. So consisting of input, which is gathering information, time taken by the controller to perform a specific task, and sending signal to the output, whether that specific task is to be performed or not. So this whole is known as scan cycle of PLC. So there are various programming techniques. First is basic programming, in which we use a linear programming, simple blocks, simple operations, first type. Second type is structured programming. Simple and clear programs are stored in the PC, where debugging is simplified and program can be standardized, easy, simple programs are there in structured programming. And the another one is ladder language. So what PLC understand is, most PLCs to operate and to store, to perform the logic operations, the ladder logic is used. In what happens is, scanning of each rung is done and it's easy for programming. Now this is known as a rung 1, rung 2, rung 3, rung 4, and its operation, like how does it read the program codes? It's from left to right, like this. Programs are executed in this way and it ends here. So this is known as a ladder logic block diagram. Now another one is function block diagram, graphical blocks for programming, and another one is statement list programming, in which we give input, output function and output, and is instruction load or an output. So this is what PLC's programming is all about. In this lecture we studied about the types of PLCs, the applications of PLCs, advantages, and what is the selection process of an PLC. So that will be all for this lecture. In next lecture we will be studying about the application of different mechatronics systems. That will be all. Thank you. Jai Hind.